Hi again. Welcome back to China Manufacturing Decoded. It's episode 122 this time. Adrian from the team here, and Renaud's back with me. Our CEO, Renaud, hi.
Hey, hi, and hi to the listeners. And today we have a nice topic about something you never want to have to do.
Right, yeah. So, but nonetheless, very useful if you do encounter certain issues with your products. So, So, what are we covering, Renaud?
Product failure and how to analyze it. So,
right.
It's something that is not very often done in a formal way, at least outside of big companies. But it's a gold mine for information, and it's a way of avoiding sometimes big mistakes and making the right decisions when the stakes are high sometimes.
Yeah, you said formal way. I suppose in a lot of factories, correct me if I'm wrong, when issues occur, it's kind of like a firefighting situation where everyone's like, "Oh, we've got to sort this out quickly. Let's just do it." And there isn't exactly a very good structure or something used for that. Is that right?
Well, you could say firefighting. Some people say scattershot. It's people like to jump directly at a solution. They say, "Oh, there's this problem. There's die casting. There's porosity. Okay, I know how to fix it. Just raise the pressure a bit, you know." And then they just, they tamper with the process, and they say, "Well, fixed." And often they don't even look at the results to make sure it's actually fixed, right? And they don't observe to see if there's some other issues. So they don't try to understand, the physics and the chemistry of what's going on. They don't try to do experiments to learn. They don't, very often what we see is that they jump to some kind of conclusion. Oh, that's what it is, Yeah, the the engineers say that, or the production managers say that, or whatever, or the boss say that, and everybody's like, hi, sir, yeah, no problem. Okay. Oh, tell us what to do. All right. Oh, thank you so much. The solution comes from the top, from your infinite wisdom. Thank you so much. We're just going to apply it. And that is very, very dangerous. This is not good. Not the right way to approach a problem.
Right, yeah, because the analysis portion of what you mentioned, that's just missing.
Completely.
Right.
They use sort of a hunch, from experience, okay, kind of makes sense that this would be causing that in a simplistic way. So just change that and, it would magically go away. At least right now, or for the rest of the day, I don't need to think about that. I can go back to sipping tea with my friends or whatever. And, they're not going to bother me and whatever. And I don't want to hear more about it. Sometimes that's the reason. But it's also when a customer complains about something, oh, yeah, we found out, oh, yeah, right. He's a supplier of the screws, they're not stainless steel. Yeah, the supplier made a mistake. And, we're getting tough on the supplier. Don't worry. In the future, it will be good and we'll pay more attention and blah, blah, blah. Okay. Thank you very much. But what tells me that in the future this will not happen again, and that's something really very often that's completely missing.
Yeah, because unless somebody remembers that exact case where they made a fix, there's nothing preserved for posterity, so they can't go back and look at some notes and say, this issue occurred, a few months ago, and this is what was done to solve the issue, which was successful, so we'll repeat that. Hopefully problems don't keep occurring, but you know what I mean, just in case. But if somebody's just done something and then moved on, then there's no record.
Yeah, that's one thing, but also what they are changing might be totally besides the point. It's you might not have any impact whatsoever. So they're not doing anything to go in the right direction. Actually, it might cause some other issues and it might make the whole thing worse. So it was the same. What we are talking about is exactly the same issue as corrective actions and preventive actions and that kind of aspect of things. But here, a failure analysis does contain some of that. You want to close the loop, which is what you mentioned. You have to confirm that the countermeasures are really had a positive effect, and over time it keeps being positive, and so and like it really addressed the root cause and so on and so forth. But at the beginning, a failure analysis is kind of different, and usually in the context it is different. So you still have that closing the loop aspect, but usually the kind of questions to ask are a bit different, and we'll cover that a little bit later in the episode.
Okay, great. So let's say we've encountered problems with the product and everyone's scratching their head, well, what are we going to do? How are we going to solve this? We could do a failure analysis, but what kind of problems would you say would normally warrant this sort of approach?
So there's two timings that are typically prone to this kind of analysis. One is when developing a new product, and two is after mass production. I mean, typically way after mass production, or it could be during mass production, by the way, but let's say usually it's later than shipment. And failure analysis, basically, that starts when there's a failure, right? So if it's during development of a new product, you have prototypes, and you build them, you put them together, you run them, you do some testing on them, and then they might not behave or function as planned, or they might fail in a certain way that was not planned. And when it's a simple product, if it's a set of playing cards or something like that, okay, it was not printed the right way, or the cardboard was not cut in the right dimensions or whatever, and the right finishing. I mean, don't get me wrong, it might get complicated with printing, but typically these kind of things, there is a relatively obvious cause, and it's not too hard to say, well, because of this, it allowed this to happen, which triggered this and this problem, right? And then if you have a little bit of experience and some quick thinking, you can jump straight to, okay, we need to do that in order to prevent it or minimize it. All right. So in that case, probably no need, except if you work for a big company that wants to be very, very structured, or if you work in a consulting firm that needs to, justify what it's doing. Now, if it's a relatively complex product, or if some of the failures are really highly dangerous, then it's a good thing to do it in a structured way, to have an engineer really like sit down, go through a proper methodology, answer the right questions, push them together, more data, and really make sure that it's a very tight analysis and it's documented and saved for later. By the way, if it's medical devices, if it's certain types of highly regulated products, then very often this would be a must, at least for sort of critical failures, right? If it's medical devices, no doubt, you have to analyze what happened, and you need to have a documented way and to show that you really addressed that issue later, based on a very logical kind of problem-solving approach. Okay. And then hopefully the next prototype, you subject them to the same kind of testing to validate everything's fine and so on. Okay. That's during development. Most of the times when I have seen failure analysis, it was way later than production. It's a batch of products get made, get shipped out, and 3 months later, 6 months later, or even later than that, there's some issues. Maybe some users complain, hey, the tablet doesn't even turn on. It's completely dead on arrival, even if we try to charge it or something like that. Or hey, the glue is coming apart. There's a rattling sound in the headphones because there's some parts going around when we're shaking it. These kinds of issues are really it's reliability issues, right? And Andrew's been talking a lot about that in some other episodes. But reliability issues, they tend to appear, all along, of course, but after 6 months, 9 months, usually it's not quality, or manufacturing issues. It's more like design issues that come up as reliability problems, right? So someone might say, wait a minute, that's just a corrective action plan based on some issues. Yes and no. It's possible to apply a typical corrective action plan template, but it's really not that great, or doing like an 8D, 8, the number 8, 8 disciplines, which is a good one when there's especially when there's an escape of some kind of defect in manufacturing. We like the 8D again, it is very structured, but I usually do not apply it for a failure analysis. It's better to have another kind of approach. The AD can work pretty well. Okay, don't get me wrong. It's not really about the template; it's about the way to think. So, but let's say there's a manufacturing batch, and then somebody goes in, tests some products, there's failure. Well, there's going to have to be some kind of investigation about what happened and everything for sure. Okay, and then the AD is pretty good, or it's more simple, maybe a corrective action plan. That's fine, but that's not what we're talking about here. When a product's been shipped out and some very serious issues, what happens is that the customer usually will get back to the supplier and say, "Oh, what's going on here? Look at all these bad reviews on Amazon. They keep saying that it doesn't work, or these steel beams, they are for the structure of the building, and the welding is really bad, and some of them we can already see some cracks and stuff like that. That's really, really bad, right?" So they got back to the supplier, and the supplier's like, "Oh, if there's some kind of excuse they can use, they will grab it and run with it, usually." Or they will say, "Well, it's the supplier, they did this wrong," and blah, blah, blah. Sometimes they will say, "Well, okay, we know what happened. It's probably very, very few units that have this problem, but we're going to make this design change, to address it." But doing a design change like that on the fly and going into production right away after that without verifying and validating it and really fully understanding all the impact of this new design is usually a big mistake, because again, you can create some other problems. So you need to do all the retesting and so on and so forth, right? And before doing the design change, which might not actually address the main causes of the issue, it's better to sit down and say, okay, let's put all of the information we have in a document, and and let's look at it in a very, very logical way, and let's see what we need to know, because maybe we need to do some extra testing, we need to get more samples to review, we need to we need to go and see something, and based on that information, what is the logical next step, right? So, and this is especially true for safety-related failures. So if you have a product and it like the structural steel, as I mentioned, maybe the welding was not done properly, it's been used in some construction of a building, and hey, it might not actually carry its weight, it might all crumble. Well, that is a very, very serious issue. And if you're the company that distributed that, what are you thinking? You're wondering, hey, okay, do I have to go back to all my customers and tell them about that? Do I need to go and gather some information? Maybe I can have access to all of the units that have been installed already, inspect them to see what's the damage, which ones are good, which ones are bad. Should I tell them right now so they stop using that batch of products? Yeah, but they're going to be really furious. I'm going to stop their construction. It's going to be crazy, right? How do I get as much data as possible to make the right decision, right? In that case, you really want a very well thought kind of analysis, right? Also, should I do a recall? What should I do?
That's a big one.
Yeah, do I actually need? Because if you're in certain countries and you're doing construction and you have this kind of problem, there are building codes, there are standards to comply with. You're regulated. You have to go back to maybe a certain government body and tell them about it, right? And then you're going to be in trouble. Yeah, but if you don't tell them, you're going to be in even more trouble when they find out. So what to do? What's your liability and so on? So what's the liability is sort of a separate topic. People usually want to talk to a compliance consultant or to a lawyer, right? But what should we do? Well, that's the kind of decision that is usually made easier based on a robust analysis of the failure. Does that make sense?
Yes, it does. It's not something that you can go into sort of half-cocked. It's because as you mentioned, the liabilities involved. Okay, we're not all producing construction materials or medical devices. And I mean, a good example of this is probably last week's podcast episode with Andrew, where we talked about the big medical device recall by Philips. Right. You can bet your bottom dollar that Philips have gone back through and done a failure analysis like this in order to actually make the decision to do what is a huge product recall and to understand why. It's interesting that it's a
must by law under the EU medical device regulations or US FDA 21 CFR code and so on and so forth, depending on the country where they sell, right? It's a must. And there is actually a whole procedure to follow. And it's all set, black and white by the regulator, and how to do a recall and so on and so forth. So it's they don't really have much of a choice, but definitely they did a thorough analysis. I mean, it cost them so much money for sure.
Yeah,
no doubt.
And unfortunately, this is where maybe something was missed during product development, and so by doing the failure analysis, we're kind of like catching up. And as you mentioned at the top of the show, this isn't ideally you won't do this. You don't want to do this, and so hopefully you never do it. But this is kind of retrospectively going through some of the steps that you would have taken during product development, right?
Yeah, there's usually some good lessons learned. Let's say if you launch some new models that are, let's say, in the same space, maybe targeting the same kind of application and so on, well, you're going to beef up your validation process for the new products. Yeah.
Okay, so without further ado, then, I mean, the really important guidance is to understand what sort of methodology we can use. Then, so there's a type of approach that we commonly use at Sofeast, and it's split into 7 steps. So why don't you take us through that?
Well, first, it's not our methodology. I mean,
no.
We get a lot of inspiration from what they call the FRACAS, failure reporting, analysis, and corrective action systems, right? FRACAS. And there's a pretty famous standard in reliability engineering, which was Military Standard 785B. And I mean, the second edition was 1980, and the first one was, I think, in the 40s. So this is not new stuff, but this is time-proven stuff, let's say, right? And then we obviously our own templates are, we adapted things, and and over time we add some questions and things like that, just to make sure we cover all the bases. But as you say, there are seven steps really. And the first step, well, actually before that, before even the first step, sort of a step number 0, is to say, okay, who's going to work on it? Sort of like the AD. What is the team? What are the timelines and so on? Sort of understanding the context of the project. But then, again, like the AD, you start with gathering all the information you can. So, what kind of product is it? What kind of information do we have about the product? Do we have specs? Do we have design files and so on? What kind of risk analysis maybe was already done, and all the typical documentation about the product. We try to see what we have, if we can have more from the client, from our client, or from the manufacturer, typically. And we try to gather, past test reports and so on and so forth. Okay. We also ask about the complaints, because usually, and that's okay. If it's during production and it was a couple of engineers testing a prototype, there's no such thing, but at least they can show what was the checklist and what they found, maybe with the video and some photos and so on. Okay, that's relatively straightforward, and we know what environment it was and so on. On mass production is different. If you've been shipping these to customers, or they've been buying it in stores for some time, and you've sold thousands of pieces, and you're getting some complaints back, well, you gotta have a log of the complaints. When was the complaint given? When was the feedback given? What is the serial number, if it's possible? And from there, what batch is it, and so on and so forth. And what is the problem? What's the problem of the product? So you really need to have a log of that, and usually, client can put that together easily and send that to us. And does it look like it's a hardware failure or a software failure? What is it, right? And then we review samples. I mean, can do these kind of things just by looking at photos, right? It's important to look at some samples, open them up, review, do a bit of basic testing to understand on our side. And usually the manufacturer will have some kind of explanation. So it's good to document that and say, well, does it kind of seem to make sense or not? But we should not be influenced by that. So it's better to keep that aside and get the engineer who's working on that to just look at the samples, look at the description of the problems, and just follow the steps logically. Later, he can review what the manufacturer says, and he can comment on that. But you should not be influenced. It's not so good. And once you've done your review, you really try to describe it in detail. And you usually need to ask more questions to maybe the customers, the end users, the consumers. The people who saw it failing and reporting the problem. Like what happened? Like, were you having your shower? Were you, was it cold shower, hot shower? These kind of dumb questions, they can really help. And where is it? Like, where were you? What city? Okay, it's all in the mountains. Okay, maybe there's a pattern here, or maybe it's all in Alaska, or it's all in the southeast, very, very dry and hot in the summer, right? So you might see some patterns, and then you go into the analysis, right? So that's number 3. So the first one was just to collect basic information and review the samples. B was just to describe based on that, and maybe gather more information. And number 3 and 4 are about the analysis. So, you might start, in many cases, you look at samples. You don't want to do destructive tests right away. Maybe you go step by step very often. First, what is the kind of things that we see, like visually or with very simple non-destructive testing? Can we already get to some kind of conclusion or at least indication of what happened? And then in a second step, it's maybe going deeper in the analysis, and maybe you have to do destructive testing and so on, right? And you really want to get to the point where you can describe what they call the physics of failure. This happened because of this, sort of in a chain, right? So if it's just a product that doesn't work, like, for example, tablets that are shipped out and then some users, maybe 10% of the users say that the battery is at 0 and they cannot even charge it. Okay, so what happened here? The BMS, the battery management system, did not automatically turn it off completely when it got down to 3%. And when it went out of the factory, some of the units were not half charged, but they were maybe 10 or 20% charged only. Okay, these two things combined, plus the fact that some of them stayed in the warehouse for that long time, means that they get to 0. And when it gets to 0 after a certain time, well, this kind of battery might not work at all. It might be dead, right? So you really break it down like this. And when it's a safety issue, which in many cases it is, because when it gets to potential unsafe situations, that's when people really get in touch with people like us to really go in depth, right?
They certainly do.
Yeah, they are quite motivated to know the truth and to get some documentation about a proper analysis and get some data. So it's more like, okay, what happened and in what situation and so on, and then it led to what issue? When does it become a failure? When does it become, or might it become, a hazardous situation? And when might it become harm, or really like a safety hazard, right? That actually comes true. So if we go back to the example of the poor welding in structural steel elements, well, there's maybe poor welding methods and poor inspection of the welding, maybe by non-certified inspectors who are not certified to the exact standard for the building code of the country. Okay, so these together with, well, it's been assembled and so on, and there's that much pressure, it's compressed by that much weight that it's supporting, and so there's that much stress on that joint, and and it starts to crack, and then you can only imagine the next steps, but you need to describe it, and then the next step is that it starts to deform, and then at one point it might break suddenly, and when it breaks suddenly, then maybe the roof is no longer supported, or like the above level or whatever, and it falls down, and people can be crushed by the weight of the structure. You want to really break it down and describe it from A to Z until possible harm, and not be optimistic, be realistic, right? You should even be a bit pessimistic here, because you're trying to imagine, okay, how can it go really wrong? And then you try to estimate, and you try to do further analysis, right? So sometimes you have some, you need to do some more tests. So, for example, there's a lot of talk about e-bike batteries that might catch fire, right? And some people's homes got on fire. And same thing for the hoverboard a few years ago. I mean, that was just terrible. Because so many Shenzhen factories jumped on that and didn't really care about how they were doing it. So then you need to confirm, okay, when I charge this product, if this happens, then can the whole product get on fire, right? So you have basically two ways of thinking of that. One way is to say, well, let's test it, and let's reproduce what might go wrong, and let's see what actually happens with with higher voltage and high heat and whatever, in the worst conditions. Let's make it happen. Let's see how bad it gets. And then if it gets bad, you can observe and you really document it. If nothing bad happens, well, that's kind of bad. That's good news for the company that was distributing it. It doesn't mean there's no risk, but at least it indicates that either the analysis is wrong or about the way you would get to an unsafe situation, or more testing is needed, right? And then the other way is that there are more and more very helpful safety standards, IEC standards, and so on, that would actually be helpful. Now, you really need a specialist for that. But for example, the IEC 62368 is great for example, for knowing what kind of materials tend to be flammable, more or less flammable. And they have different PS1, PS2, PS3, different degrees, different levels of, let's say, likelihood that a material would go on fire. And then you collect the information from the suppliers of these components, hopefully of the main components of the product. I mean, hopefully they give you the information. Hopefully they also give you some test reports on that. That's even better. Maybe their components are certified. That's even better, right? If not, you might have to get some of their components and actually test it to see how flammable it is. And then based on that, you can draw a conclusion, right? This is an example, but it's not that unusual. It's not that unusual. Okay, so just to recap, and that's the big chunk of the analysis, right? Get the basic information, describe it with a quick look, then go into first analysis, then go into deeper analysis, and really, try to find in documentation anything that could help you. And then, well, what to do actually, right? That's the next step.
Yeah.
Number 5, how to contain the problem. What do we need to know right away? So it might include some testing of the past batch products to confirm certain things. It might include, obviously, stopping the sale of the product. It might include maybe telling the customers of a certain batch to put the products aside and not use them until further information is known, but it might be unsafe, right? So that's already a big jump. But if there's a real safety issue, that's really something you don't want to skip. And sometimes the data are so bad, it's like, recall, right? Extremely expensive. But some cases it's better to recall now than having people die and a bunch of lawyers suing you.
Yeah.
Because that's even more expensive. Then the last 2, that's the corrective action plan, right? So what is the plan? What are the countermeasures? Which ones are higher priority? And who's going to have to do what, basically? And sort of also thinking, how can we actually confirm, let's say we do that. How do we validate it that it had a good effect or not, right? So already planning for the way to double confirm and say, yes, this countermeasure has been put in place and it is carrying the desired effect, right? So planning ahead, this is really the plan. And then the last one is to actually do it and follow up over time, right? What is actually done and was effectiveness verified or validated, and what did not work, and so on. And if you learn some new stuff there, you might go back to the earlier steps and rethink some of the assumptions that or some of the wrong data maybe that you were using, right? Or missing data. So yeah, that's it. A lot of people come to us for the analysis and a bit of testing to understand. They sometimes trust their supplier, the manufacturer, to actually implement the right corrective actions. But that's fine as long as the manufacturers actions make sense, which is not always the case. But if it makes sense and they seem to know what they're doing, yeah, why not? And then, but it's important. The one thing I would stress is it's important to close the loop. It's important to confirm it's in place. It's important to validate it. Very often, maybe there's a new design or new component or something. Well, you have to redo some testing, right? Because maybe it's introducing new problems. So, and keep collecting data, keep having your log of complaints, and that's really useful, basically. So, that was the failure analysis.
Yeah, well, let's hope we never need to use it, but you've gone through the approach there for future. If you are unfortunately in a situation where you do have these problems coming in and you need to find out what's happened and what should we do. So yeah, really solid approach there. Thanks, Renaud. We do have the service on our website for this. So you've mentioned people come to us and ask us for help. So I'll leave the link to that in the show notes. So yeah, if you are suffering from an issue and you need help from engineers to sort it out, take a look. Perhaps we could help you. And I referred to last week's episode with Andrew where we spoke about product recalls caused by issues in DVT, part of the MPI process. That's quite related to what you've been talking about today, Renaud. So I'll leave the link to that as well. Yes,
quite related. All right. Thanks, Adrian. And well, then you'll hear from us, at least some of us in the team next week.
Thanks again for listening to this podcast brought to you by the Sofeast Group. We're on a mission to provide you with everything you need to manufacture effectively in Asia, including inspections, auditing, new product development support, contract manufacturing, 3PL warehousing and fulfillment, and much, much more across Asia's key manufacturing areas. Visit us at sofeast.com, that's SOFEAST.com, to learn more and get help. If you've enjoyed the podcast today, please do rate, review and share because it will really help others discover us too.